Hello, today we will discuss the interim fixed restorations. They must be performed efficiently because they are made during the same appointment that the teeth are prepared, and they must be maintained and sustained inside the mouth until the final prosthesis is being delivered to the patient. They have some important requirements like the pulpal protection. They must seal and insulate the prepared tooth from any irritation that may affect the pulp. Also, they must maintain the periodontal health around the teeth that is being prepared, and they should have an occlusal compatibility, which means that they must maintain the occlusal relationship between the opposing teeth. If they are not present, some teeth may have an horizontal movement which may alter the occlusal and make the chair side modification of the occlusal surfaces take more time and more effort from the test. Although the interim restorations have a strength that is less than the final restoration, but they must be enough to prevent any tooth fracture and preserve the teeth until it gets the final restoration. The connectors of an interim fixed denture must be over contoured, and it is made on purpose, especially in the posterior region where the aesthetic is not so important. And the reason for the over contouring is to increase the strength of the interim abutments. Now let's discuss the materials that are used and the ways of doing this, whether it is direct or indirect. The most available materials that are used, they are either the PMMAs or the polymetacrylate, the base-acryl, and the light polymerized resin. So the PMMAs are most popular for the CAD/CAM fabrication. As for the resin and the acryl material, they can be done during the clinic from the dentition. It is usually done by getting the negative reproduction of the patient teeth, whether before the preparation or after the preparation, when we do a diagnostic cast and then do the negative impression for it. And this waxing can be manual or digital. Now let's discuss the methods that can be done to achieve the interim restoration. Is using the custom template of a thermoplastic sheets, which is the vacuum pressed plate. It is heated and adapted to a stone cast via vacuum or air pressure. Let's see these different methods of getting the impression. This is by getting with an alginate, and then it is casted. This can be from a beeswax, and this is the vacuum sheet that we discussed earlier. It is filled with resin or an acrylic material. Then it is fixed to the teeth, and then it is polymerized. Also, another type of interim restoration is the polycarbonate shell. Or another method is to do a silicone impression over the cast. When we take the impression before the preparation, we remove the proximal projections to facilitate the complete resetting of the material and allow it to the access to get out of the tray. We trim it from the palate and the facial using a sharp knife or a scissor. These are the thermoplastic sheets, and they are vacuumed. Another method is using a fixed pre-mained tooth, whether they are polycarbonate, this is it, or a cellulite, or they are this is for the anterior teeth, and for the posterior they are made of aluminum shell, whether it is anatomic, which has impressions, or non-anatomic, or an aluminum, or a tin, silver, anatomic. These are. Now for the cementation. The polycarbonate are cemented with resin, but they are not chemically bonded to it, and we do not do any bonding, and we use the flowable composite for the cementation. As for the stainless steel, it is primarily used for children with extensively damaged primary teeth. They are trimmed and adapted with contouring pillars and lotted with a high strength cement, so it can be used as a long-term interim restoration for children on deciduous teeth. And it is suitable for this application because stainless steel is very hard and can sustain the occlusal load. They are usually available in different sizes and shapes. Here we can see how the CAD/CAM manufacturing of an interim restoration can give us so realistic and well-defined results, and that they were milled from a resin disc. They are made of polymethylene methacrylate. They are multi-layered, but we must take consideration about the allergy that some patients may possess, because we have seen a 20% incidence of sensitivity of the patient using a monomer interim restoration. We have this case where the PMMA Pontic was placed for 6 days. After that, an allergic reaction has happened with labral ulcerations and gingival ulcerations. Now let's see the step by step. We do a normal, this is after the preparation. We do a normal alginate impression. It is favorable to use a subgingival margins, and then the cast is coated with a resin gypsum separating medium. We're using a brush. Then we use a thermoplastic sheet and vacuum press it on the cast. The polymer is injected inside this mold and can be in the direct form, can be injected and setted in the mouth of the patient, and then the extensions is trimmed, or in the indirect situation, and they are, after the polymer is being injected, it is reset on the cast, and after its polymerization, it is trimmed to get the final interim restoration. Here they are giving us an advice when we are doing the direct method and the material is getting to the rubby stage. When it reaches this, and it is usually 2 minutes, we engage the facial and the lingual surfaces with a forceps and rock the interim restoration buccolingually to loosen it. Then we remove it from the patient mouth. The forceps may make small indentations in the resin, but this is not usually a concern for posterior units. The defects can be smoothed later during the finishing procedure. Now for the cementation, we clean the internal surface of the interim restoration using a phosphoric acid for 15 seconds. Then it is air dried and unfilled with resin, flowable composite, and the finish line is coated with a thin film of Vaseline to make the removable easy. Then we apply a flowable resin in the finish line for adaptation of the prepared crown, and the interim is seated on the tooth. Then we brush out the flowable resin onto the external surface of the crown, and then we light it. Here we see that the flowable resin is used to improve the adaptation to a finish line, and it fully covers the finish line. Then using a brush, we brush it on all surfaces before we light cure it. Another tip is to place the interim restoration in warm water to hasten the polymerization and improve its physical properties of the PMMAs. It is not necessary when we are using an bis acryl. Here they are mentioning the step-by-step application of the polycarbonate crown foams. They are usually used as an interim restoration on the single anterior teeth and premolars. We select their width with a divider. Then we select the appropriate crown size that resemble the size that we took in the mouth. Then we see the appropriate height, and start the cervical trimming until we reach to the appropriate height. Here we see that it is tall a bit, and we can see the bleaching of the gingiva, so further modification is done. Then we clean the teeth and the Vaseline. Then the shell is filled with the resin, and it is settled. When the resin, we remove the excess, is immediately removed after the crown has been positioned, and there must be an initial stability that can be tested using the tip of an explorer. Some retention must be felt. Here we see the adaptation of an aluminium crown using pillars, and the cervical line is being smoothed using a burr. Zinc oxide eugenol it is the most used interim cement, and it showed a success for many years due to its strength and its favorable pulp effect, in addition to its acceptable sealing properties. We should not use the zinc phosphate or the zinc polycarboxylate or the glass ionomer as an interim cementations, because they have high strength that make them removable. The removal difficult, but the ZOE cement is easily removed, and it allows the restoration to be reused when additional service is needed. But when we are using the stainless steel shells as a long-term interim restoration for the deciduous teeth, we use a long-term lutting agent like the zinc phosphate and the polycarboxylate or the glass ionomer. Now let's discuss the fiber reinforced composite fixed prostheses that are considered a long-term interim restorations using a fiber reinforced material. We will get a brief explanation of their types and their shape. This type of material provides strength, and they have good flexure strength, and their physical properties make them ideal for a long-term interim restoration when it is needed. It is usually made of glass or polyethylene or carbon. And they have shape. Each of them has shape that we will see under the microscope. For example, the fiber orientation make this differ in the physical properties of this type of material. For example, the polyethylene weaves, like the rebound and the construct care, has a shape that is different from the glass one, and we will see them in a bit. For example, here we have seen that the woven polyethylene, we said that the construct care is the commercial type of this woven fibers. The braided polyethylene is the rebound, and the unidirectional long glass fiber, like this one, its commercial name is the fiber core or the pentron. The unidirectional, this one, long glass fibers, when we have a polymetacrylate outer membrane, is the Everstick, GC America. So how this differ in their shape of the fibers affect their physical properties. Here we see that they say that the glass materials with a unidirectional architecture exhibit flexure properties that are superior to the polyethylene materials with a woven or braided architecture. Because of their good handling characteristics, the braided and the woven polyethylene products are useful for periodontal splints. The current materials provide excellent aesthetics, good handling characteristics, and good flexure properties. Let's finish up with this case where we have a preparation of these crowns to do a bridge. In this case, we use the Penteron Clinical Technologies, which is the company, and the material is called the fiber core. It is a unidirectional glass material. What we did is it was a hand fabricated technique where we made a thin coping of body of this composite that is adapted to the die. Then a bar of multiple layers is made as a fixation between the pontic region, bonding them together. Here we did a continuous strip of the material that is bonded to one end of the pontic bar and then wrapped around the axial surface of the coping while being polymerized. And this is the occlusal view of the completed substructure. This is the completed prosthesis with particulate resin veneers on the model. And this is the tissue side view of the completed prosthesis, showing the internal adaptation to the preparation design of the abutment teeth. That's it. Salam.